this class. In the previous session, we discussed and we solved some problems from the exercise 1.5, and also we come to know how to rationalize the denominator. Okay, in this session we are going with another exercise, the last exercise from this chapter. And before we are going with the exercise problem, let us try to understand what are the topics which comes under this exercise. The another important topic called as the laws of exponent. So laws of exponents. Based on this laws of exponents, we are going to solve some problems in the next exercise. So without wasting our time, let us know about this laws of exponents. Look at the board. There are some 6 laws which I have given here. Let us try to understand here. So for the first one, that is a to the power of m into a to the power of n is equals to a to the power of m plus n. First, before that, you must know that what is exactly this a and m means. So whenever if you get a problem like this a is called as a base, and this m we call it as a exponent. Okay, and also while you are writing this, the base should be the bigger one than the exponent, and also the exponent should be like this itself. You can see here how I wrote like that itself. You should write like a m like this at all. Okay, that's a very important point. Okay, now let's start with this. First step, laws of exponent. A to the power of m and into a to the power of n. If you observe these two, the bases are common here. The base of a and a itself, and in between those two we have multiplication sign. And when we consider the exponents are different. If I get a number like this, so then I can write it in the form of a to the power of m plus n. For example, let me take an example, that is 3 to the power of 2 into 3 to the power of 3. So now observe the bases are common. If I if I put the dot, means it is nothing but a multiplication. Okay, you don't need to write like this itself. Even if I take the dot also, it is multiplication. Remember. So bases are common, the exponents are different. Then I can write this one as writing only one base, means 3 and 2 plus 3. I added the exponential. That's it. Got it? Yes. The second laws of exponent here. A to the power of m whole to the power of n. Try to observe what I am saying. A to the power of m whole to the power of n. There is only a one base and 2 exponents over here. Okay, so this one that I can write a to the power of m into n. I can multiply these 2 exponents. For example, 4 to the power of 2, 4 to the power of 3. Then I can write this one as 4 to the power of 2 into 3. That is 4 to the power of 3 2s are 6. Got it? Yes. Next is the third one, a to the power of m divided by a to the power of n. So here the bases are common, exponents are different. So then I can write this one in the form of like this, a to the power of m minus n. So a to the power of, because base is same, a itself, that's why I can write that a to the power of m minus n when m is greater than n, means this m is greater than n. How? Just observe here. We have an int like here. See, a to the power of n, if I take into the numerator, it will become a to the power of minus n. Because there is a plus sign over here, then it will become minus n. Okay. So when it becomes a minus n, observe, I'm just explaining. Okay, a to the power of m, when it goes to the numerator into a to the power of minus n, isn't it? Okay, when it goes to the numerator, and then there will be a multiplication like this. Now bases are common, exponents are different. What I supposed to do? Observe the first one. How the link it is. I should add. I should add means that a to the power of m plus minus n, because the exponent is in negative. So then a to the power of m plus into minus, because I should remove the bracket, then multiply the sign, plus into minus minus n. See? Correct now? That's what we have written here. Okay, this is the procedure, but you can remember only this much, it's more than enough. Okay, exactly. Now the fourth one, a to the power of m, b to the power of m, into a to the power of m into b to the power of m. Now if you observe the bases are different but the exponent is common, then I can multiply the base a into b whole to the power of. For example, 3 to the power of 4 into 4 to the power of 4. Bases are different but exponents are common. Then I can write this one as 3 into 4 whole to the power of 4. So then 3 4s are 12 whole to the power of 4 or to the power of 4. That's it. Next. This one just now explained. So when I take this, the denominators into numerator, the exponents will become negative. So if it is in a positive, then it will become a negative. Just imagine that it is negative. So like 1 divided by a to the power of minus n. So then when it is goes to the numerator, it will become a to the power of plus n. Simple. Change the sign. That's it. Okay, the last one, a to the power of 0. A to the power of 0 is equal to 1. You can take a to the power of 0, n to the power of 0, p to the power of 0, anything. The exponent, if it is 0, means the value is always 1. Pause the video and write it neatly first. Then we go with the exercise problem. Now here is the exercise problem. The first we find, we have sub-questions. In that first sub-question, there is 64 whole to the power of 1 by 2. Let us write the solution. First take the problem, 64 whole to the power of 1 by 2. Now observe 64. If you observe 64, you can recall the squares, like 64 is a square of 8. 8 square means 8 into 8. It's 64, right? Exactly. Then 8 square is nothing but a 64 whole to the power of 1 by 2. So you must know all these things. It's a mind calculations. For example, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49, 8 8s are 64, 9 9s are 81, 10 10s are 100. So now 8 8s are 64. See? Now if you observe this one, it is in the form of a to the power of m whole to the power of n. Then I can write this one in the form of a to the power of m into n. First one, 8, 2 into 1 by 2. Write down properly the exponents. So 2 into 1 by 2. 2 is in the denominator and this 2 is in the numerator. These 2 will get cancelled. And remaining it is nothing but 8 to the power of 1, or else you can write only 8 times. No. That's all. Okay? Yes. Let's go to the second one. 32 to the power of 1 by 5. First take the question 32 whole to the power of 1 by 5. Now if I try to think about the squares, 32, 4 4s are 16, 5 5s are 25, 6 6 are 36. Okay, what else I can do? So how we can find out? You do one thing, you can do the 32 now. So there is an even number at the end. So then let me take 2. 2 ones are 2 6 are 12. 2 8s are 2 4s are 2 2s are 1 2 3 4 5. Right now. So then 32 I can write it as 2 to the power of 5. 1 2 3 4 5. 5 times if I multiply I will get 32. This is another way to find simple. Then 32 I can write it as 2 to the power of 5 whole to the power of 1 by 5. So as usual the same one. So this one I can write it as 2 to the power of 5 into 1 by 5. 5 will be cancelled and remaining this 2 to the power of 1, or you can write 2 itself. Okay, yes. The next one, the third one. Okay, so third one, it is (125) whole to the power of 1 by 3. Why I am writing? Yes, that's your homework problem for this session. So in the next session, let's go with the next main problems. Until then, stay tuned, stay safe, keep on working and do your work properly and do your homework properly.